Hello, beautifuls. This is Atleen, and welcome back to my channel. Today, let's discuss IP version 6. And the best thing about IP version 6 is that we will never run out of these addresses. In IPv version 6, we will have 128 bits versus with IP version 4, we had 32 bits. So 120 bits, wow. So this means we can assign billions of addresses. So before we get started, let's discuss this section, which will be on CCNA 200-301 and on CCNA 200-301 1.8. It states we must be able to configure and verify IP version 6, addressing, and prefix. Also 1.9, compare IPv6 address types. 1.9a, global unicast. 1.9.b, unique local. 1.9c, link local. 1.9.d, anycast. 1.9.e, multicast. 1.9.f, modified EUI 64. And to your right is 3.3, configure, verify IP version 4 and IP version 6 static routing. 3.3a, default route. 3.3.b, network route. 3.3.c, host route. 3.3.d, floating status. So what we do have here is a network portion and a host portion. And we don't discuss a subnet mask, even though there are bits that refer to the network. We usually, with IPv6, don't call that a subnet mask. We call it a prefix length. Think of the prefix as being the network address and the length being how many bits are we using for the network address. And we have bits for the host also. We have 128 bits, which is a huge number to write out. So as you see on the bottom there, I tried to write it all out on the bottom, and it's so many, I had to write it really, really small. There are so many bits to write out, which is why we use hexadecimal. Yay! We can write hexadecimal so basically we can write hexadecimal like what's on the screen. And this is a list of decimal numbers on the left in the first table from 0 to 16. 16 different values. And on the right are the corresponding hex values 0 to F. We can represent as many as 16 different values with hexadecimal. Instead of writing a 10, we write A for that 10. And for the E, we write the letter E for 14. So A, B, C, D, E, F, which is what you see on the screen to your right. The hexadecimal equivalent of 10, 11, 12, 13, 14, and 15. So we can squeeze in more information into one hexadecimal digit, and let's go further. So if I have 16 possible values, how many bits does it take to represent that? Four, because 2 to the power of 4 is 16. So if we have our IPv6 address and have the letter A, that represents 4 bits. It's going to be whatever equals a 10. So if we have a 10, it's going to be 8 plus a 2. So as you can see on the board, 8 plus a 2, and let's look at the small table here, and I'll have 1, 2, 4, and 8. As you can see, 1, 2, 4, and 8. So again, if I have a 10, that's going to be 8 plus 2. So the A would break down into 1, 0, 1, 0. 1, 0, 1, 0. So whenever we see one of those hexadecimal numbers in the address, we have to realize that it is representing 4 bits. So let's do the math here. We will have 8 quartets. A quartet is a group of 4 hexadecimal digits. That's the definition. How many bits is that? Is it 16 bits? That's in a quartet? We are going to have 8 of these. What is 8 times 16? It is 128, and that's the number of bits we have in the address. And the bits is not written as something dot something. So everything is separated by a colon, as you can see on the screen. 4 accessible digits separated by a colon, and so on. As you can see on the screen are examples. Full IPv6 address and shortened IPv6 address is on the right. As you can see, those are some great examples. So, as you can see, we can shorten the addresses. If we have a quartet, one of those groupings of 4 hexadecimal digits, and they're all zeros, as you can see on the screen on the very bottom, is all zeros, and then at the end there's a 1. The lower part, the very, very last one on the left-hand side. And then when you go to the right, is dot, dot, which is a colon, dot, dot, colon, and then number 1. So let's use a few rules. If we have zeros at the beginning of a quartet and 1, like you see, we can leave out all the zeros and just put down the 1. Number 2, what if we have a quartet containing all zeros? We can combine all the zeros and replace it with a colon, as seen on the screen. Also, a double colon, and it's going to know that we have 3 quartets containing all zeros. Now remember, obviously, we can only use this trick only one time in a IPv6 address, because if we have a couple of colons up front and a couple of colons at the end, there's no way to know how many quartets were representing by each colon. So what we have done, the trick already, the double colon, as you can see at the end, all zeros, we just use a colon. Thank you for watching. Thank you for subscribing, and I wish you well with your studies. Have a good night.